Today we are going to continue looking at chapter 1 with a little bit of a change of pace. Today we are going to look at graphing. So by the end of the day today, we should be able to create labeled and scaled graphs, and then we should be able to use the data from our graphs to create a mathematical model. So graphing is hopefully something that we should be pretty familiar with from our math and our previous science courses. But today we're going to take a little bit of a deeper look at what we need to all include in our graphs or work with these graphing problems. You are going to be given a set of data. So if we look at this example, we have you and your friend want to make some money, so you decide to become famous TikTokers. Doing your due diligence, you decide to research how much money you make based on how many times a TikTok video is watched. Your data is found below. So our end goal here is to be able to graph this data and make it happen. So we know with a typical coordinate axes, we have a y and an x-axis. So when you guys are given a set of data, you need to decide which variable or which data is going to go on the x-axis and which data is going to go on the y-axis. The answer to that question is finding which variable is our independent variable and which variable is our dependent variable. So our independent variable, this is the variable that you are controlling. Okay? And the independent variable, that's the one that's going to go on your x-axis. On our y-axis, that's where we're going to have our dependent variable. Okay, and our dependent variable is often found by what is being measured. Or in other words, it is what is being determined by the independent variable. Oops. Variable. All right, so if we go back up and look at our data, we're seeing how much money you make based on how many times a TikTok video is watched. So the amount of times a video is watched is how much money is made. Okay. So since you are controlling the times a video is watched, and that is then determining the money that is made, the times the video is watched is going to be your independent variable. And then since the money made by the TikTokers is determined by times the video is watched or is dependent on the times the video is watched, that is going to be our dependent variable. So the money made is going on a y-axis, okay, because that is being measured based on how many views we have. And what is our dependent variable? We can come down and label our graph axes. So since the times watched was our independent variable, we are going to put that on our x-axis. So it's super important that you guys label each axis with a variable and the unit that that variable is measured in. So if we come back up to our data table, we're going to see that the times watched is measured in views. So we need to include that when labeling our graph axes. We need to show that the unit for x-axis is views. Okay. We'll do the same thing for our y-axis. So we know the variable on our x or on our y-axis is the money that is made. Okay, again, this is the variable. We also need to include the unit. So if we come back up to our table, we're going to see that the money made is measured in dollars. So we need to put that along that y-axis as well. Just as a quick aside, okay, there is a difference between our variable and our unit, okay? When talking about our x and y variable, we are talking about our category of focus. Okay, so we're talking about the times our videos watched or the money that was made. When we're talking about our units, that is going to be a label. Okay, and that label is just going to describe the variable more. So that unit tells you more about your category of focus. And it is super important that you guys include both of these when labeling the axes of your graph. Axes labeled with what is be measured on either side. Now I can go ahead and start the process of plotting my data. So before I am able to plot my data, I need to scale my axes. Okay, so I need to decide what numbers I'm going to have along the bottom and what numbers I'm going to have along the side. So if I look at my x-axis, my times watched, okay, that's this guy over here. I can see that my lowest view is going to be 1,000, and my highest view or my highest x value is going to be 10,000. So I need to be able to have up to 10,000 on this bottom axis here. Okay, so I'm going to just open up. Okay, notice how I do not have each of my x values on my axis here. That's a-okay. All right, just as long as you have equal spacing between each label or between each scale, that's all that matters. Okay, so again, you don't need all your values on the x-axis, you just need equal spacing between them. All right, now we're going to do the same thing for our y. So if we look at our y values, our dependent variable, the money made by our TikToker, we can see that our lowest value is 0.9 and my greatest value is 9. So that means I need to be able to go up to 9 on my graph. So again, I'm going to go by 2. And it is a-okay that not every single one of my points is going to be on our scale here. Okay, just as long as you have equal spacing between each one. And labeled, I can go ahead and start plotting my points. So if I look at my first point, my x value is 1,000, and my y value is 0.9. So I'll come down here to my graph, find about where 1,000 would be, and about where 0.9 would be. Okay, I'm going to do that for each one of my points. So my next point is 2,000 and 1.8. So I'm going to say that's about there. And again, it's okay that it's an approximation. My next point is 4,000 views and 360. About right there. Okay. My next point is 6,000 views and 540. And my last point is 10,000 views and $9. So we're going to say that's right about there. Okay, so again, I'm just looking at my x value and my y value for each point and then finding about where that would be on my graph. Once I have all my points graphed, I can go ahead and draw a line of best fit. So my goal in drawing that line is to include as many points as possible on that line while keeping a nice straight linear relationship there. Really nice about creating graphical representations of data is that we can then use this graph in order to make predictions. And the way we are going to do that is by writing the equation for our line. we use the general formula y equals mx plus c for the general equation of our line, where m is our slope, or the rate of increase for our graph, and b is our y-intercept. And remember, that y-intercept is where our line hits the y-axis for our y value when x is 0. Okay, so let's take a look at what the equation for this line is going to look at. Instead of writing y in our equation, we're going to be just a little bit more specific. We are going to say what that dependent variable actually is. So if we look at our graph, we can see that the money made is on our y-axis and is therefore going to be our dependent variable. So instead of saying y equals, we're going to say our money made is equal to. All right, so notice how I switched out what our dependent variable actually was to be a little bit more specific rather than just y. The next thing we have to find is our slope. So if you guys remember back to your math class, our equation defines slope between 2 points, x1, y1, and x2, y2 is rise over run. So how much does our graph go up by divided by how much it goes over? So to plug in values, what we're going to do is we'll take our two y values and find that difference. How much did our graph go up by? Then we're going to divide that by the difference between our two x values. So to find the slope of this line, we can pick any 2 points from our data table. It's typically good practice to pick the first data point and the last data point so that you can get a full range or full idea of what your data actually represents. So we'll use the data points 1,000 and 0.9 and 10,000 and $9. Okay. So then when we plug these into our equation, we'll subtract our two y values. So 9 minus 0.9 divided by the difference of our two x values. 10,000 minus 1,000. And when we plug that in our calculator, we should find that our slope is 0.009. Okay, so that's what we're going to plug in for our slope in our equation. Okay. Something we're going to want to attach to that, we're going to want to say what that slope represents, because we have 0.009 what. Okay, so we're going to want to include units for our slope. Okay, so to find the units for our slope, what we're going to do is we're going to think about how did we calculate it? Okay, we calculated that slope by doing y over x. So we're going to find the units the same way. We're going to do our y units, or dollars, divided by our x unit of views. Oops, I forgot to say there. There you go. Okay. So now we know our slope is $0.0009 for every one view. Alrighty, so now that we know our slope, we can look at our next part of the equation. So if we come on over, the next thing we're going to have is this x. And just like with our dependent variable, instead of just putting x in our equation, we're going to say what our independent variable actually is. Okay, so we're going to come over here to our x-axis and see where our independent variable is, and that is going to be the times watched. So instead of just putting x, I am going to put times watched into my equation as my x variable. Okay? So we're being more specific than just x and y. We're saying what is actually on our x and y axis. The last part of our equation is that y-intercept, okay, that b. Okay? That y-intercept tells us our y value when x is 0. So in order to find that, what we're going to do is we're going to plug in 0 for x, okay, because we're trying to find where our line hits the y-axis when x is 0. So in order to do that, what we're going to do is from our data table and plug those values into our equation so far and solve for what b needs to be in order for that relationship to be true. So we're going to pick a point, and let's say we do 1,000, 0.9 again. Okay, so what we're going to do is we're going to plug in our y value for our money made. We know our slope is 0.0009. And then we're going to plug in our x value. That times watched is 1,000. We need to solve for what b is in order for that relationship to be true. So when I end up solving for b, I'm going to find in this case that b is equal to 0. This means that when you have 0 views on your video, you're going to make $0, okay? Because we're trying to find what the y-axis is when our x value is 0. So in our equation then, we're going to add our y-intercept, which in this case would just be $0. Just like how we did with our slope, make sure you include units for the y-intercept, okay? So when we do all that, we are going to get this as our final equation. Okay? So the money we make is equal to $0.0009 per view times or multiplied by the times watched plus $0. We can then use this equation in order to make predictions about our data. Also use the program Logger Pro to graph our data and create our equation for the line. So you guys log into Logger Pro. This will be the initial screen that you see. We can tweak it to be a little bit more specific to our problem. For instance, we know what our x variable is. We said our x variable was the times that our video was watched. So if you double click on the x variable, you can rename it. And we're going to rename it to times watched. We can also input units. And we said our units for x variable were views. Once you've done all that, you can click Done. And you're going to see our x variable and units pop up down here on our x-axis. We're going to do the same thing with our y. So double click on our y and put in our dependent variable, a money made, and our unit there is dollars. Once you click Done, then we can see that pop up on our y-axis. Okay. What we can do then is we can input our data from our previous data table. 0.9. So we'll just keep doing this until all of our data is inputted. And we can see our data start to pop up on our graph. One thing when you're doing these, do not put commas in for your values. Ignore the commas. Okay, so we can now see once all my data is in, we can see it pop up on the graph here. If it was too hard to see, we could click on this little A to auto scale, and it'll zoom in for us so we can see our data more easily. Okay. So much easier to graph our data this way. We can also use Logger Pro to create our equation for the line. All we're going to do is click on this button up here where it says R, or linear fit. So when we click on that, sometimes it'll glitch out and you'll need to highlight all your data. Click R again, and then we can see it tells us our slope is 0.0009, so the same thing we got earlier, and the units of that slope, dollars per view. So it tells you that whole thing right there. And our y-intercept here is 1.6 times 10 to the negative 15th. That's pretty close to 0, what we got earlier. So we can then use this slope and this y-intercept and plug it into our equation for our line. And we end up getting the same thing we had earlier. The money made is equal to $0.0009 per view times the number of times our video was watched plus $0. And then again, we can use that equation for our line to make predictions. To predict if I have 8,000 views, how much money would I make? Okay. If you guys have any questions as you're working, please let me know. Otherwise, have a fabulous day.